This is Cambridge Chemistry Channel, question number 11, 9701 specimen paper 22 paper 1. So this is the question 11. When K2MnO4 is dissolved in water, the following reaction occurs. MnO4 2 minus plus BH2O CMnO4 minus 2 plus DMnO2 plus EOH minus. What could be the values of A and C in the following chemical in the balanced chemical reaction? So this is the redox reaction. This is the redox reaction in which manganese 4 oxide is oxidized and reduced, and A, this is B, this is C, this is D. So what could be the value of A and C in the balanced chemical equation? First, find out let's find out oxidation state of MnO4 2 minus. So this is equal to minus 2 Mn plus 4 minus 2 is equal to minus 2. So Mn minus 4 to the 8 is equal to minus 2. Mn is equal to minus 2 plus 8, or Mn is equal to plus 6. So the oxidation state of Mn is plus 6. Now MnO4, MnO4, this is equal to minus 1. Mn plus number of atom 4 minus 2 is equal to minus 1. Mn minus 8 is equal to minus 1. Mn is equal to minus 1 plus 8. So in this compound, oxidation state of Mn is equal to plus 7. This is plus 7. And now look at the MnO2. Yes, MnO2 is equal to 0. Mn plus 2 minus 2 is equal to 0. Mn minus 4 is equal to 0. Mn is equal to 4. So oxidation state of Mn4 is plus 7. So the change in from plus 6 to plus 7, this is increase in oxidation state. This is oxidized, and change in plus 1. So this is oxidized and reduced at the same time, disproportionation reaction. So over here decreased, and the change is minus 2. So this is minus 2. So this is redox balancing. This is plus 1 into plus 1, and D is equal to 1. So similarly minus 2 into 2, and this is going to 2. So MnO4 C is equal to 2. So this is the only option 2. C is equal to 2, and 3, how it is 3. So this is 2 MnO4, and this is 1 mole of MnO2. So 2 plus 1 is equal to 3. So A is equal to 3. So C, A option is 3, and C option is 2. So this one option is correct option. Now next question is, methanol can be produced from hydrogen and carbon monoxide. What is expression for Kp? This is very simple equation. You know, Kp is equal to partial pressure of product or divided by partial pressure of reactant. So Kp is equal to partial pressure of CH3OH divided by partial pressure of H2 raised power to 2 and partial pressure of CO. So this is wrong. H2 2P PH2 and CO CH3OH P raised power to 2. This is CH3OH. This is wrong. This is wrong because reactant over product, and CH3OH and P raised power to 2 and P in partial pressure of carbon monoxide. So this option is correct option. This is wrong, this is wrong, this is wrong. Now come to the 13th question. 13th question is 4 gram of powdered calcium carbonate, MR is 100, are added to 100 centimeter cube of 0.1 mole per dm cube hydrochloric acid. The volume of carbon dioxide produced is recorded every 30 seconds. You know, time is 30 seconds and total volume of carbon dioxide is produced. So the difference over here is 30 and 70 to 88. The difference is plus 18 and this difference is 13 and this difference is 9 and this difference is plus 6 and this is 4 and this is equal. So 120 at 120 and 120 volume, it means that rate is constant at this stage, mean reaction is over. Yeah, in other words you can say that rate is constant or reaction is over when volume is 120. At 210 time and 240 time, reaction is over. So now look at the volume of gas which is going to decreased as the reaction is progressed, going to decrease. Now which row of the table is correct? Why the rate of reaction changes with time? Fewer collision between the reactant molecules occur. Fewer collisions between the reacting molecules occurs. So these two are correct. More collisions, no, this is incorrect because as the time passes there are reactants are used up and there is less collision between the particles takes place. Now these two are correct. Now why the reaction stops? The calcium carbonate is used up, the hydrochloric acid. Now for this, why the reaction stops, we can see the reaction that calcium carbonate react with HCl to form calcium chloride plus water plus CO2. To balance this reaction, place 2 over here. The mass of 4 gram calcium carbonate and 100 centimeter cube divided by 1000 into 0.101 moles. So first find out mole. 4 gram divided by mR of calcium carbonate is 100. So mole of calcium carbonate is, calculate moles of calcium carbonate. So over here now need to calculate the moles of calcium carbonate and hydrochloric acid. 4 divided by 100, 4 divided by 100, this is equal to 0.04. This is equal to 0.04 mole of calcium carbonate. Now 100 divided by 1000 is equal to into 0.1 divided by, so this is equal to, the mole of hydrochloric acid is 0.01. So now find out that this 1 mole of calcium carbonate react with 2 moles of HCl. Now 0.01 divided by 2 and this is divided by 1 to make these two reactants equal. So this is equal to 0.04 and this is equal to 0.01 divided by 2 is equal to, this is equal to 0.01 0.01 divided by 0.01 divided by 2 is equal to 0.005. So this is the limiting reactant, this is limiting, and calcium carbonate is excess reactant. This is excess, so it means when the limiting reactant is used up, reaction is over. So fewer collisions between the reacting molecules occur, the calcium carbonate is used up. This is wrong because calcium carbonate is excess, and fewer, this is correct option because the hydrochloric acid is limiting reactant and it is used, when it is used up, reaction is over. So this is limiting and this is correct. So B is correct answer. Limiting reactant. Now next question, which statement about ideal gas is correct? Which statement about ideal gas is correct? Ideal gas have finite volume. Ideal gas has
no intermolecular forces. Okay. In the real gas, you can have weak intermolecular forces, but the weaker the intermolecular forces, the more ideal it gets. Okay. Question 15.
so. Which question number 14? Which statement about ideal gases is correct? Ideal gases have finite particles, volume, and no intermolecular force of attraction. So ideal not finite particles, and ideal gas have zero particles. So these two are correct. Zero particles, this is correct, this is correct. With no intermolecule, so the insignificant. So for ideal gas, this option is correct, because in ideal gas there is a ideal gases have zero particles volume and no intermolecular force of attraction, so this option is correct. So next question is, a mixture of gases consists of 12 gram hydrogen, 42 gram of nitrogen and 4 gram of helium. What is the mole fraction of hydrogen in the mixture? The mole fraction is equal to individual mole of gas divided by total mole. So first find out moles of hydrogen. Hydrogen is 12 divided by 2. Nitrogen is equal to 42 divided by 28, and helium 4 divided by 4. So this is 6 moles. Nitrogen, calculate, let me calculate. 42 divided by 28, this is equal to 1.5. This is 1.5 and this is 4 gram divided by 4 is equal to 1. 6 plus 1.5 plus 1 is equal to 7.5, 6, 7.5 and 2.5, 8.5. Total mole is 8.5. Now calculate hydrogen mole. 6 divided by 8.5, 6 divided by 8.5 is equal to, this is 0.705, this is equal to 0.71. So this option is correct option. Is that clear? What is the definition? What is the definition of bond energy of the Br covalent bonds? The energy required to produce 1 mole of bromine atoms in the gaseous state. The energy required to produce 1 mole of bromine atoms in liquid state. So atomization, bond energy is equal to atomization. The energy required to produce 1 mole of bromine atoms in the gaseous state. 1 mole of bromine atoms in the gaseous state. In the gaseous state, the energy required to produce 1 mole of bromine atoms in the liquid state. This is incorrect. The energy required to break 1 mole of Br bonds. Yes, this is correct option, because 1 mole of bromine atoms, not 1 mole of bromine atoms, 1 mole of Br bonds in gaseous state. So liquid state is incorrect. So this is correct option. C is the correct option. The next question is 17. Which graph correctly shows the relative melting points of the elements magnesium, aluminum, silicon and phosphorus plotted against their relative electronegativities? So across the period, this is the third period elements. Across the period, electronegativity is going to increase. and melting point because magnesium in first period first comes metals, then non-metals. So this is, and silicon is the covalent giant covalent structure. Aluminum is metallic bond and phosphorus is non-metal simple molecule. So this is incorrect. So this is magnesium, then aluminium. Silicon is covalent molecule, and this is, so this is the trend of third period, melting point electronegativity. And this is wrong because phosphorus not is the strong electronegative element, so this is incorrect. So over here again phosphorus is strong, so B option is correct option because magnesium is present in group 2, aluminum is in 3. So magnesium aluminum is stronger metallic bond than the magnesium, and silicon is covalent molecule, giant covalent molecule, so has many strong covalent bonds which require high energy to break, so that's why silicon at the top, and phosphorus is simple molecule and with strong electronegative because electronegativity is decreased across a period, so this option is correct. An excess of magnesium oxide is shaken with water. The resulting mixture is filtered. This is filtrate W. Magnesium oxide is insoluble in water, so resulting mixture is filtered. This is filtrate W. 2 drops of dilute sulfuric acid are added, and any observation. So no observation because there is magnesium oxide is insoluble in water, sparingly soluble, almost insoluble, so it is in the form of residue. There is no water is in the filtrate, so no reaction with the sulfuric acid. An excess of barium oxide is shaken with water. Barium oxide dissolve in water to form barium hydroxide, and resulting mixture is filtered. This is filtrate X. Barium hydroxide is filtrate S. 2 drops of dilute sulfuric acid are added, and any observation is noted. Barium hydroxide, when if 2 drops of sulfuric acids are added to form insoluble barium sulfate and water. So this is solid white precipitate. So filtrate higher pH. When barium hydroxide is formed, the pH is higher. Higher pH is X. Filtrate of higher pH. Observation of addition of sulfuric acid to the filtrate of higher pH. No change. This is incorrect. White precipitate is correct. So D is correct option. Sample of magnesium carbonate are placed in crucible R and S. The sample in crucible R is heated until there is no further change, further loss in mass, and then allowed to cool. Cool. The sample in crucible S is left unheated. Dilute hydrochloric acid is then added to both crucible. On adding the dilute hydrochloric acid, which observations are correct? Magnesium carbonate are placed in crucible RS. R is heated. Magnesium carbonate decompose on heating to form magnesium oxide and carbon dioxide. This is R. And there is S is unchanged because heating, no heating is provided to the S. Magnesium carbonate without heating. This is S. Now dilute hydrochloric acid is then added to both crucible. Magnesium oxide in R, HCl is added, magnesium chloride plus water, and when added in S, where magnesium carbonate plus HCl to form magnesium chloride plus water plus CO2, carbon dioxide. So now on adding the dilute, which observations are correct? R gas produced, gas produced. B gas produced, no gas produced. Gas R gas produced, yes. And S on adding sulfuric acid in R, this is R, sorry, this is R, no gas, this is wrong. And S, yes, gas is produced in R, no gas is produced, so this is no gas. This is also wrong. No gas produced R, this is correct. Gas is produced in S, yes, because when hydrochloric acid react with magnesium carbonate, carbon dioxide gas is produced, so this is correct. So C option is correct. When concentrated sulfuric acid reacts with sodium iodide, the products include concentrated sodium iodide, NaI, plus sulfuric acid. The products are sulfur, iodine, hydrogen sulfide, H2S, and SO2. Which statement is correct? Hydrogen sulfide is the product of reduction reaction. S is plus 6, and over here S is minus 2, S is 0. Is the reduction reaction. Iodide ions are stronger oxidizing agent than the sulfate ions. Hydrogen sulfide is the product of reduction reaction. Yes, because plus 6 to minus 2, this is the product of the reduction reaction. Iodide ions are stronger oxidizing agent, so iodide ion is stronger reducing agent. This is incorrect. Iodide ion is reducing agent. Stronger oxidizing agent than sulfate ion. Sulfur, so this is incorrect. Sulfur atoms from the sulfuric acid are both oxidized. So plus 6 going to minus 6, minus 2. In over here it is plus 4, over here 0. So plus 0 to 6, this is reduced, plus 6 to minus 2, this is again reduced, and plus 4, 6 to plus 4, again reduced. So this is also incorrect. Sulfur atoms from the sulfuric acid are oxidized to make sulfur dioxide. Sulfur atom from the sulfuric acid are oxidized to make sulfur. No, sulfur is from sulfur atom from the sulfuric acid is reduced to form sulfur dioxide. So this is also incorrect. So first option is correct. A option is correct. A solution of sodium hydroxide reacts with 3 moles of chlorine under certain conditions. The reaction produces 5 moles of sodium chloride and 1 mole of X. The only other chlorine containing products. Uh, what is the formula? The reaction produces 5 moles of sodium chloride and 1 mole of X and only other chlorines. There are two reactions when chlorine reacts with sodium hydroxide. When it reacts with cold sodium hydroxide, it forms NaCl, NaClO and water. So over here 3 moles. So let's balance this reaction. Sodium and sodium to place 2 over here and hydrogen 2, oxygen 2, 1 and 2. This is balanced reaction. This is 1 mole. So there is another reaction when chlorine react with hot sodium hydroxide. So to form NaCl plus NaClO3 and water. So this is 0 and oxidation state of -1 and in NaClO3. This is equal to 0. Sodium is plus X plus 3 minus 2 is equal to 0. So Na plus 1. This is over here plus 1 because individual charge of sodium is plus 1. Now 1 plus x minus 6 is equal to 0, x minus 5 is equal to 0, x is equal to 5. So over here oxidation state of plus 5. To balance this reaction, the change over here is 0 to minus and over here plus 5. 0 to minus 1. So this is decrease in -1 and Cl2 0 to plus 5, over here plus 5. So -1 into plus 5 and this is 1. To balance this reaction, 5 NaCl and 1 over here 1 mole. So 5 NaCl, 5 and 1 6. So 6 sodium hydroxide and 5 Cl and 1 Cl. So this 6 over here 2 3 moles of Cl. So the X product would be NaClO3 in this reaction. Redox reactions are common in the chemistry of group 7 elements. Which statement is correct? Bromide ions will reduce Cl2. You know that bromide ion will reduce Cl2 but not I2. This is incorrect because this is option, this is group 7, Cl bromine iodine reactivity decreases downward, so highly reactive halogens displaces less reactive from its compound, so Br negative plus Cl2. Br negative ion will reduce Cl2 but not I2. Br negative will reduce, yes, act as a reducing agent and Br negative plus I2. Yes, this is less reactive, so it cannot reduce this iron. This is wrong. This is correct. Cl2 will oxidize bromide but not iodide ion. Cl2 will oxidize both bromide as well as iodide ion. So this is correct. This is incorrect. Fluorine is the weakest oxidizing agent out of fluorine, chlorine, bromine, and iodine. No, fluorine is the strongest oxidizing agent out of fluorine, chlorine, bromine, and iodine. Iodide ions are weakest reducing agent out of fluoride ion, chloride ion, bromide ion, and iodide ion. Iodide ions are the weakest reducing agent. Iodide ion is the strongest reducing agent. Yes, but not iodine. Yes, iodine. So this is iodide ion is the strongest reducing agent and fluorine is the strongest oxidizing. So this is also incorrect. This is also incorrect. So bromide ion will reduce Cl2 but not I2. Yes, this is correct option. Okay. Now 23. Which statement describes a trend in period 3 between every pair of adjacent elements from sodium to chlorine? Which statement describes a trend in period 3 between every pair of adjacent elements from sodium to chlorine? From every adjacent element, the atomic radius decreases. No, the atomic radius increases. Atomic radius, the first ionization energy decreases. The first ionization energy increases across the period. Atomic radius decreases. Atomic radius decreases. Nuclear charge increases. Atomic radius increases. So this is incorrect. This is the melting point decreases. Electric Electrical conductivity, yes, melting point decreases. Sodium to chlorine melting point is increases. This is incorrect. This is incorrect. Melting point decreases because across the period sodium to chlorine first comes metals, then non-metals. So till chlorine is a gas. So melting point is decreased across the period because look like this. This is chlorine melting point. Next question, nitrogen forms pollutant oxides Y in a car engines. Further oxidation of Y to Z occurs in the atmosphere. In this further oxidation, 1 mole of Y reacts with 0.5 moles of oxygen molecules. Which statement is correct? Nitrogen forms pollutant Y in car engine. Further oxidation of Y to Z occurs in atmosphere. Nitrogen in car engine form nitrogen monoxide in the limited oxygen. Further oxidation of Y to Z in the atmosphere. In this further oxidation, 1 mole of Y reacts with 0.5 moles of. So 0.NO plus O2 to form NO2. 1 mole of Y reacts with, so this is half, and this is 0.5 moles of gaseous oxygen. Which statement? Compound Z does not react further in the atmosphere. This is incorrect. Yes, it can react further with oxygen in atmosphere. A molecule of Y has 15 electrons. Molecule of Y has 15 electrons. Molecule of Y to Z. Nitrogen forms protein Y. Molecules of Y has 15 electrons. Nitrogen has 7 plus oxygen 8, so 7 15 electrons. The oxidation number of nitrogen increases by 1 from Y to Z. Oxidation number of nitrogen from Y to Z, Y to Z. Oxidation number over 1 from by 1 from Y to Z. Nitrogen, so this is plus 2 over here, minus 2. This is plus 2. This is incorrect option. This is correct. The oxidation number of not Y to Z, this is plus 2. This is also. Y is a non-polar molecule. Yes, nitrogen monoxide is a non-polar. So this option, B option, is correct. Y is a non-polar molecule. This is also correct. Incorrect. Because no difference of electronegativity between nitrogen and oxygen, so that's why it is non-polar. So the correct option is B. Next question, 25th question is structural isomerism and stereoisomerism should be considered when answering this question. Each of the following carbonyl compound is reacted with NaBH4. Okay, the product of each reaction is heated with Al2O3 at 600 degrees centigrade, giving either only one isomer or a mixture of isomers. Only one isomer or mixture of isomers. Structural and isomerism. Structural isomerism and stereoism should be considered when answering this question. Okay, each of the following carbonyl atom is, this is reducing agent. Carbonyl compound is reduced. The product of each reaction is heated with Al2O3. So this is butanol, CH3, CH2, CH2, CHO. So when react with NaBH4 to form primary alcohol, butanol, CH3, CH2, C double bond O, CH3. So this is secondary alcohol when react with NaBH4. Secondary alcohol. Pentane 3 on CH3, CH2, CH2, pentane 3 on, C double bond O, CH2, CH3. This is pentane 3 on, and propanone CH3, C double bond O, CH3. So it is formed again secondary alcohol, pentane 3 on. This is secondary alcohol, and this is propanone changes into CH3, CH2, CHOH, CH3. Okay, the product of each reaction is heated with Al2O3 at 600 degrees centigrade. This is elimination reaction. This is elimination reaction giving either only one isomer or a mixture of isomers. So butanol, primary alcohol. So look at this, CH3, CH2, CH2, CH2OH. When this elimination reaction occur, so this is CH3, CH2, and CH double bond CH2. This is not correct. This is incorrect because this is 1, 2. Two isomers are formed. And butanone. So in case of butanone, CH3, CH2, CHOH, and CH3. So when react with aluminium Al2O3 at 600 degrees centigrade, CH3, CH2. So two types of compounds are formed. One is CH3, CH double bond, and CH2 and CH3. This is one compound. This is another possibility, CH3, CH2, CH double bond, CH3. So these are the two possibilities. This is the one product, this position isomers, and also stereoisomer, geometric isomerism, cis trans isomerism. 2 CH and CH3. So look at this. This is cis CH3, CH double bond CH, and CH3, H, CH3, CH3 and H. This is trans isomer, and C double bond, C, H. This is cis isomer. CH3 and CH3. So this is correct, I think so. This is the best option, B. Now look at the, let's check this compound as well. Pentane 3-on. Pentane CH, CH3, CH2, C double bond O, CH2, CH3. So when react with NaBH4, CH3, CH2, COH, H, and CH2, CH3. So if it react with elimination reaction, so this is one possibility, CH3, CH double bond, CH, CH2, CH3. 1, 2, 3, 4, 5. This is another possibility, CH3, CH2, CH double bond, CH, CH3. This is 2, this is over here 2, the same isomer, 2 and 2 same. Same structure, and CH double bond CH. So this, I think so, this is not correct option, not forming most isomers, so this is incorrect option. And propanol, now come to the propanol, CH3, C double bond O, and CH3, CH3, CHOH, and CH3. When react with aluminum oxide, CH double bond, CH2, CH3, and if it is on other side, CH2, CH3, CH double bond CH, the same molecule is formed. So this is also incorrect option. The correct option is B. Question number 26. The drug cortisone has the formula shown. In addition to these, those chiral centers marked by an asterisk, how many other chiral centers are present in the cortisone molecules? How many other cortisones molecules? Chiral carbon, the carbon which is surrounded by four different groups. So this is 1, 2, 3, no, CH2, no, CH2, no. So this is chiral carbon. This is one chiral carbon, and this is, I think so, same CH2, and this is carbon 1, 2, 3, and 4. This is another chiral carbon, and this is also, this carbon is surrounded by four different groups, so this is again chiral carbon. So D option is correct. Okay, next question is, an alkene is reacted with acidified manganate ions. The organic product has a relative molecular mass greater than that of alkene by 34. An alkene is reacted with acidified manganate ions. The organic product has relative molecular mass greater than that of alkene by 34. Okay, what conditions should be used? uh, Alkene by 34, mass is greater than alkene. What conditions should be used? CN, alkene mean carbon to carbon double bond, or 34 means CN H2N is equal to 34. This is equal to 12N plus 2N is equal to 34. 14N is equal to 34. N is equal to 34 over 14. So it means 14 and no, this is not correct. Look at this. Alkene is reacted with acidified manganate ions, MnO4. The organic product has a relative molecular mass greater than that of the alkene by 34. Okay, if OH, when react with OH, when cold concentrated in MnO4, so there is double bond, so OH is formed. Molecular mass greater than that of the alkene by 34. So it means oxygen 16 plus 16, because when cold concentrated manganate react, diol is formed. Diol is formed. So with addition of two OH group, 16 16 and hydrogen 1 plus 2 is equal to 34. Molecular mass greater than that of alkene by 34. Cold concentrated manganate ions cold concentrated uh, greater than C double bond, not extensive oxidation. Yes, no, this is not correct. concentrated manganate, cold concentrated manganate, extensive oxidation takes place. So this is incorrect. So when cool dilute, this is the cold dilute. When react with cold dilute, then COH diol is formed, where double bond is present. So addition of 34, mass is greater than 34. This is best option. Hot concentrated sulfuric acid is not correct because when it react with carbon to carbon double bond, so this double bond is going to break and carboxylic acid is formed, COOH. So this is incorrect. This is again incorrect. Okay, if you like this video, please like and subscribe this channel. Okay, love is